Welcome! Let's take a look at an example of applying L'Hopital's rule to find the value of a limit. Recall that L'Hopital's rule can be used to evaluate limits that are of an indeterminate form. Specifically, though, we have to ensure that the indeterminate form is either 0 over 0 or infinity over infinity. In the case that we have one of the two indeterminate forms, then the limit of the ratio of the numerator and denominator is equal to the limit of the ratio of the derivative of the numerator and the derivative of the denominator. So let's go ahead and take a look at the limit as x approaches 0 of 2x minus sine of 2x, that quantity, divided by the quantity x plus sine of 2x. Now, if I try to evaluate this limit, since it appears that we have something that might be a continuous function, when we do that, what we end up with is that our numerator is 2 times 0 minus sine of 0 over 0 plus sine of 0. So our numerator and our denominator are both 0. So this is indeterminate of type 0 over 0. So indeterminate of type 0 over 0. And 0 over 0 is one of the eligible forms to apply L'Hopital's rule. So we will go ahead and do that. So this is going to be equal to, and because I'm going to apply L'Hopital's rule and the appearance of the limit will change, we're going to go ahead and annotate our equal sign to indicate the application of L'Hopital's rule, so that someone reading our work will know how we arrived at what follows. So this will be equal to the limit as x approaches 0. Now be careful, do not confuse L'Hopital's rule with the quotient rule. L'Hopital's rule tells us that we will take the derivative of the numerator. So the derivative of our first term is 2 minus the derivative of our second term. That will be 2 cosine of 2x. And then we take the derivative of the denominator. The derivative of our first term is 1 plus, and then the derivative of our second term, 2 cosine of 2x. Now, at this point, we can think about applying or evaluating the function at the x value for our limit. We would have 2 minus 2 times cosine of 0, 2 times 0 being 0, divided by 1 plus 2 times cosine of 0, again 2 times 0 being 0. Now we do know that cosine of 0 is equal to 1, so we can replace both of those with 1. And then we end up with 2 minus 2 times 1 over 1 plus 2 times 1. So our numerator is 0, our denominator is 3, and 0 over 3, or 0 divided by 3, is not an indeterminate form. It is, in fact, equal to 0. So the limit of our function here is 0. Let's take a look at a second example. Let's look at finding the value of the limit as x approaches infinity of the natural log of x over x. Now, natural log of x has certain behavior as x approaches infinity. So in your mind, you should have this mental image that the natural log of x behaves something like that, something like what is captured in this graph. So as x approaches infinity, our natural log function also approaches infinity. So the numerator of our function here is approaching infinity. Also notice that as x approaches infinity, our denominator approaches infinity. So we have another indeterminate form. And in this case, our indeterminate form is of type infinity over infinity. Again, that is a form for which we can directly apply L'Hopital's rule. So we'll go ahead and do that. Again, we must warn the reader that what follows is the result of applying L'Hopital's rule. And so we'll have the limit as x approaches infinity. And keep in mind that this is not the quotient rule, this is different. And we want the ratio of the derivative of the numerator to the derivative of the denominator. So the derivative of the numerator is 1 over x, and the derivative of the denominator is 1. So basically what we have here is the limit as x approaches infinity of 1 over x. And we know that as x approaches infinity, 1 over x will approach 0. So here's the limit of our second function we wanted to consider. Let's take a look at one more function. Let's find the value of the limit as x approaches 0 of sine of 3x over 5x. Now, as x approaches 0, 3x approaches 0. So sine of 0 is 0. And 5 times 0 is also 0. So we have an indeterminate form and indeterminate. And that form is of type 0 over 0. So again, that is one of our eligible forms. And so as we apply L'Hopital's rule, we'll remember not to use the quotient rule because we're not finding the derivative of this original function. Rather, we're comparing the rate at which the numerator grows and the rate at which the denominator grows. So f prime of x over g prime of x. So this equals, and again, warning the reader that what follows is the result of L'Hopital's rule. We have the limit as x approaches 0. The derivative of our numerator is 3 times cosine of 3x, and the derivative of our denominator is 5. At this point, we can try and evaluate this limit directly by substituting 0, and we end up with 3 times cosine of 0 over 5, and we know that cosine of 0 is 1. So we have 3 times 1 over 5, or more simply, 3/5. So that's the value of our limit for this particular function. I hope you find this helpful.